Hey all, doing our nightly weathercast once again, Wednesday, December 7th, 75th anniversary of Pearl Harbor here. And you can see we've got a lot of winter storm advisories, warnings in the Portland, Oregon area. These are all watches, and let's see, one of them is... I don't remember this whole color scheme that they got here, but yeah, they're looking at winter storm watches and winter weather advisories for that area. So this is pointing out that we've got a lot of cold air sinking south through the northwest with Pacific systems coming inland. Still blizzard advisories for northern North Dakota, and a few winter weather advisories starting to show up in Texas. So let's go ahead and check out the surface map. And we'll start with the thickness and isobaric analysis. This will help us pin down exactly where the fronts are. Let's see here. Let me just check over on chat and make sure everything is good. Don't see any complaints. And yeah, we're from the Dallas-Fort Worth area here. Just a little ways out in the country, southeast of Dallas. So, a lot of thickness banding in the southeast U.S. right here. Not so much in Florida or Cuba. So this is showing that we have a cold front in the Gulf extending south of Texas, and looks like it's pushed all the way through Utah and Nevada and New Mexico. This is a rather unusual front because you probably are aware they tend to bank up against the Rockies like that when they come south. So this is actually a very deep air mass. And it extends offshore as a warm front and probably an occluded front like that. And this is probably what's going to be coming inland and affecting the Washington, Oregon area. Also looks like a little bit of a wave in Northern California there. So there's quite a lot going on here. And the system we had that was creating that blizzard there in North Dakota and Minnesota, that's moved off to the northeast. And we're kind of left with lake effect snows there in the Great Lakes area. And we'll pin that down just a little bit better with a surface analysis. Haven't even looked at this, but I've plotted this up, and let me get this centered on Texas to start with. So we can see northerly flow here in Texas, and you can see a lot of cloudiness. There's a lot of marginal VFR, a little bit of IFR there in southwestern Arkansas. And by IFR, we mean visibility's below 3 and ceilings below 1,000 feet. But offshore, lots of 70s. 72 right there, 74, 76. So that front is not too far offshore, and it hasn't even gone through Brownsville. So they're still up at 74. So that's kind of the picture we're looking at right there. So not a whole lot of cold air coming south. Still, well, 21, that's getting down there definitely. Looks like we have to go north to find some of the deeper air. And let's see, 4 to 5 degrees in North Dakota, and then we start seeing sub-zero readings in Alberta and Saskatchewan. And it looks like there's still quite a bit of cold air to go because they've still got northwest winds. Normally, when all the cold air is depleted, their winds turn around to southwesterly or westerly. And that's not happening here. In fact, we go way up in the Northwest Territories. We see very high pressures. 1056 millibars right there. That's going to be, I don't know what that is in inches. Let me see if I can calculate that real quick. 1056 divided by 33.8636. 31.18 inches of mercury. So that's going to probably peg out your barometer there. And the center of that high looks to be pretty much right in this area. So we've still got a little bit of this cold outbreak to go. Now, I was going to talk about upper fronts on this webcast. So let's go back down to Texas. We know right now that front is just offshore, just south of Corpus Christi and Laredo. And so keep that in mind, because we're going to go up and look at the higher levels and learn a little bit about this. All right, we're going to go up to 850 millibars. So let me get this chart centered. Now actually we're going to start with a surface chart. We're going to keep a little consistency in here because we're going to use similar charts up at 850 and 700. So let me stretch this out. Okay, so are you able to see the front offshore? You can see a little bit of a difference in the winds here, northeast winds there in southwest Louisiana and easterly offshore. And you can see a color gradient. But we know from the surface analysis that the front is something like that. So let's go up to 850 millibars. That's going to be up at 5,000 feet. Okay, do you see the front on this chart? Is it offshore in this area? No, we've got south winds north of that, south and southwest and west. Looks like you have to go all the way up to Dallas to find that. So for sure we've got it between Lubbock and Midland and south of Texarkana. So this is actually a little further north than what we had for the surface front. And this is kind of what we call the slope. This is the backward sloping with height of the cold front, and it always slopes upwards and towards the cold air. So what do we have at 700 millibars? Got a little bit of a different picture here. The front does still exist up there, and I'm going to put that roughly from maybe Lubbock to the Red River and south of Memphis. And then we'll go up to 500 millibars, which is up at 18,000 feet. Yeah, it's even further north up there. So that would probably constitute the upper cold front. And then that starts transitioning into, in this case, a tropopause fold. And I'll show that to you briefly. So basically, surface front here, 850 millibar front was here. 700, which is 10,000 feet, was here. And then at 500 millibars, 18,000 feet, it was even further north. So let's look at a cross-section from Houston to southern South Dakota. So we're going to cross Houston, we're going to cross Dallas, a little bit west of Oklahoma City, and around, what's the name of that city where, I'm trying to remember, west of Emporia. Okay, I'm drawing a blank here. Anyway, now you notice that right where that 700 and 500 millibar front is, we've got the jet stream. This is a 300 millibar chart, and we're showing the jet stream like that. And let me go back and put the surface front, the 850, the 700, and the 500 millibar front. So you can see that the jet stream pretty much overlies this gradient. These are all kind of tied together. Now we're going to use wind grids. Now I've prepared a cross-section already so we don't waste too much time. Now what you're looking at here, I know wind grids is a little difficult to read. This is going to be the surface. The vertical grids are 100 millibars, so this is going to be 800, 600, 400, and 200. 200, that's going to be 39,000 feet. 400, that's going to be at about 24,000. 600, that's going to be about 15,000. And 800 is going to be roughly 6,000 or 7,000 feet. And then on the horizontal, this is Houston, just off the left side of the right side of your screen. Dallas is going to be about right there. 35, Oklahoma City right there. And then Pratt, Kansas. And then anywhere from here up is going to be Nebraska. So this cross-section is showing the jet over northern Kansas right there. And you can see a bit of it extends higher and higher across Texas. So it's picking up some of that stronger gradient at the surface. So you're probably wondering, can we actually see the front? Let me try doing this. I'm going to try plotting just temperature. Okay, yeah, let me try boosting the interval right here. Contour interval 4. Okay, can you see the front on here? Let me give you your grid labels. It's not very easy to detect, is it? Because when we're looking for fronts on the regular charts, we're looking for temperature contrasts on the horizontal. But the vertical temperature contrasts are much more significant, and they kind of overwhelm the temperature differences at the surface. So what we like to use is potential temperature, where we normalize everything to where any temperature reading, like up here, we're going to read it as what it would be if we descended it adiabatically down to 1,000 millibars. So this kind of gives us a way of kind of like normalizing the temperature field and showing which temperature gradients really matter. So let's replot the temperature field using potential temperature. Okay, so when we do that, we come up with this. And the yellow is still the isotax, where the jet stream is. And the gray here, this is the... Let me try redoing that just a second. Because what I wanted to do is put up the grid. So it makes a little more sense. But now you can definitely see the front, because it's where we have the tightest packing of the potential temperature lines. So we're probably looking at something like this. See where that gradient is really tight there? And it looks like there's probably another one, maybe kind of like that. And anyway, this folds upward into, basically transitions upward into the tropopause way up in Nebraska and South Dakota. And above that, this is all the stratosphere. And let me paint out where the stratosphere is. It's going to be kind of like that. And it actually folds downward with the frontal boundary. And this is all taking place, this whole area, this is over Oklahoma and Kansas where that's happening. And then as you go down into Texas, we get the shallower cold front near the surface, and you go further south and the front is even lower down to the ground. So this is kind of how everything is tied together in the vertical. And I'll just show you one more thing we can look at. Got to bring up the menu again. Let me do that. Okay, so this is what we saw just now. The potential temperature lines or isotropes in gray, wind in yellow. Now we're going to add on something else. We got the humidity in green and the momentum in red. I'm not going to get into momentum too much, but basically the parcels like to stick around with the same levels of red of momentum. And what it's showing is that it's showing a little bit of this folding going on right here if you look strictly at the red. And there's even a little bit right here. I don't know if you can get folding around a subtropical jet, but it kind of looks like that's what's going on here. But this definitely here is polar front jet folding. That's where the stratosphere is being drawn down into the transverse circulations around that jet over Oklahoma and Nebraska. So there's all kinds of dynamic stuff going on that you wouldn't think of just looking at this. So basically the troposphere is, or the tropopause is folding underneath this jet that you're seeing right here. And then as you go further south, it becomes the upper front, which stacks down to a surface front. So once you start thinking in terms like that, when you do your analysis, you can kind of factor that into your forecasting. For example, if we go back down to 850, we know that we've got southerly winds, and that's going over the surface cold front. And when we have that, we know we have isentropic lift, and that's the reason for all the clouds, all the stratocumulus that you saw when we started this webcast on that video. That's all this 850 millibar flow riding over the top of this front. But eventually we're going to catch this northerly flow as the 850 and 700 millibar front moves south, and we're going to see probably a little bit of clearing in the low levels tomorrow and the next day. Unless we get cyclogenesis out here, then all bets are off at that point. All right, so there's your quick and dirty tutorial of upper fronts and cross sections, and I figured this was a good time to roll that out. Let me take a look at the chat and see if there's any comments about that. I'll just address a few of the questions. Best way to learn about severe thunderstorms, chasing and reading radars. Probably the Storm Track website. There's a lot of stuff on there, and they've got archived posts going all the way back to the early 2000s. You're going to find a whole bunch of stuff in there. Also, the UCAR trying to remember the name of they've got a meteorology classroom type thing. It starts with Met something, Met Ed. Okay, yeah. Go to UCAR Met Ed in your browser. They've got a ton of stuff. A lot of this is actually intermediate level. So when you pick up a lot of the basics, you can run with that and find some courses in here. And some of them are kind of basic. You can start with basic courses like predicting convective cessation for aviation forecasters. That's probably a little bit more technical, but I do know they have some basic things in here you can select. So you're going to go to topic areas, and you're going to go down to maybe mesoscale meteorology or satellite or radar meteorology. And I do know they have some storm spotter things in here. See, weather radar fundamentals, that's going to be a good one to start with. So yeah, go and check that out, and I'm sure you can find a course that works well for you. And of course, I do have my books at weathergraphics.com. Please check those out, but I do need to let you know I've got kind of a run on the books, and I may not be able to ship all of them before Christmas, so just bear that in mind. Weather prediction, yeah, Jeff Habby, good stuff there. And Amazon, yeah, there's probably a few good ones on Amazon. All right, so let's go into the forecast and see what's coming our way. Here's tonight's chart. We know it's been drilled into our head. Our front is down south, so we know that. And if you'd like to do some extra credit, take a look at the soundings out in this area and see if you can find the frontal boundary in Arizona and Utah. And I'll give you a little hint using Texas. I'm going to pull up the Fort Worth sounding. This is the Fort Worth sounding just 1 hour ago. And you can see the frontal boundary aloft at 850 millibars. It's located right there. And we know that's the frontal boundary because you can see the moisture. It slopes up and to the right along with the slope and the temperature. Because when you slope to the right with temperature, that indicates an inversion. So this is basically a frontal inversion. And if you go up to Oklahoma City, you're going to find that a little bit higher. Maybe a little bit deeper, maybe up to 825, not a whole lot. But as you go, let's see, up to Springfield, Missouri, now we catch it up here. Now it's up at 750, about 8,000 feet. And above that, you can kind of see some of the clouds. This is probably a bit of isentropic lift above the frontal surface. And depending on the weather pattern you have, this can be an excellent area for embedded storms to develop, especially if you have an upper level low to the west. You can have very steep lapse rates above that frontal inversion, and when you do your mixed layer or your most unstable cape from that layer, you'll find a bunch of positive energy up above that. So we don't have that situation going on right now, but we might catch one this winter, and if we do, we'll go over that. So going into our forecast, when you join us tomorrow for the webcast, our map is going to look like that. Not a whole lot different from what we have today, but that front will be making some headway very strongly down into Mexico. Now we've got the winter storm coming in, upper level system coming in from the west. Then for the webcast on Friday, Thursday, that's probably going to be one of the coldest days for Texas. And then we get high pressure moving off to the southeast, and now we start getting a little bit of return flow that should start warming things up a little bit in Texas. But this precipitation in the Pacific Northwest. That's going to be the next system coming inland. Fix that a little bit right there. Okay, then for Saturday, you can see that Pacific system moves across the northern plains. And this is our picture for Saturday evening. It's got a little bit of the look of a Alberta clipper. And north of that, got a little bit of a snow shower and snow activity in Minnesota, around Minneapolis and La Crosse, Michigan. And that's going to go pretty rapidly to the east, and then by Sunday night, that's going to be over the Great Lakes and start getting a little bit of lake activity, snow going, and looks like a new cold outbreak into Texas, very weak one. Then for Monday, things start getting some cyclogenesis and some frontogenesis out in Wyoming and Nebraska. So front probably looking kind of like this. New system coming together. And look at that, 480 thickness. That's way off the top. Yeah, see 480? This is probably the core of a lot of the polar airs up there over Manitoba. That's some very cold air there. Then for Tuesday next week, here comes our next outbreak of cold air. Going to get a norther here in Texas. Then for Wednesday, cold day for the Central Plains. Another system coming inland. And it looks pretty cold for the northeast right there. A lot of cold air advection. Thursday the 15th, high pressure continues to move into the eastern U.S. and continued cold air advection out there. Looks like the lee side low develops in Colorado, so things should start warming up for the southern and central plains. But things are starting to look a little bit stormy here in the Pacific Northwest. Probably some snow there in the higher elevations. Okay, then for, let's see, Friday. Looks like another system getting started up here. Looks a little bit like an Alberta clipper there. And then for Saturday, it's like a new outbreak of cold air coming south. And after that, 19th to 20th, this is getting way out there. Looks like one more hurrah for the Arctic air. And then on the 22nd, looks like not a whole lot of change in the pattern. I think we're just going to be kind of locked into this pattern of Pacific systems coming inland and moderately weak or moderately strong Arctic outbreaks kind of oozing southward underneath that. So that's going to be the picture over the next couple of weeks there. So I think that's going to do it for me. And let me check out on the chat, see if there's anything else. Yeah, weathergraphics.com. So yeah, definitely hit that up and you'll probably find a few books that you like. Anyway, I appreciate you watching and hopefully we'll see you all tomorrow at 8 o'clock. Thanks.